Hey everybody, happy Tuesday. So I just wanted to make a quick video for those of you who couldn't make it to the Zoom sessions today so that I could go over what we talked about and kind of give you an overview of today's assignment. So what you're looking at right now is something that should look pretty familiar by now. It's a weather map. So our new scope that we're starting today is about predicting weather. So we spent a lot of time in today's Zoom session going over how we predict weather, the things that contribute to weather, and some of these symbols that you might see on a weather map. So this particular weather map was put out yesterday on the WGN Tom Skilling weather blog. And by looking at the maps on this, without even looking at the headlines, I could have looked at these pictures and said, well, it looks like tomorrow is going to be colder and rainy. And well, what do you know? Outside right now, it is cold and rainy. So how can we tell that? What do these symbols mean? What are those little zigzagging arrows on there? What are the L's and the H's on there? What do the colors mean? These are some of the things that we're going to talk about. So as I mentioned, we are starting a new scope, and the title of this scope is Predicting Weather. We're going to get into more detail in later discussions about why we get certain weather patterns, but for now we're just going to kind of say, well, it's mainly caused by the uneven heating and cooling of Earth's surfaces. So you've got things like land and water, and they heat up and they cool down at very different rates, and that gives us weather. Another thing that is a major contribution to weather patterns is the sun's energy. We know from the water cycle that the sun's energy is what causes evaporation and puts water vapor into the atmosphere, which in turn gives us condensation and precipitation. So what do we call a professional whose job it is to predict the weather? Well, that's a meteorologist. In this picture here is Tom Skilling. This is the guy that makes those weather blogs that we've been looking at for half the school year now. By definition, a meteorologist is a scientist who predicts the weather. You can see they usually stand in front of a weather map and give a weather forecast. What is a weather map, you ask? Well, it's simply a map or chart that shows the weather conditions at a specific point in time over a specific region. So if you look at this picture, this is showing what I would call, I don't know, maybe the central United States. You can see Chicago's on there, and it shows us partially cloudy, it looks like, 56 degrees. And obviously this weather map is only going to be accurate for a specific point in time, because in a month from now, is it going to be partially cloudy and 56 degrees there? Probably not. So weather maps are typically temporary and can show us at a specific place in a specific point in time what the weather will be like there. And when we mention the weather forecast, we are simply talking about a prediction or estimate of future events, especially of the weather. So it's basically what we expect the weather to be like. Another key vocab term for this scope is weather pattern. And a weather pattern is just similar weather for a certain number of days. So this is usually based on past data. So we could look at this week in May from past years, and we can identify a pattern. We can say this is typically, I don't know, maybe a warm, rainy week, and that would be a pattern. We can use these patterns to help us predict future weather. So when we discuss the weather, we have to define two really important terms. These are weather fronts and air masses. So a weather front is a warm or cool mass of air. And this air mass is basically just a large body of air. I mean, these things can cover over 1,000 miles or more. And they develop and retain specific characteristics of pressure, temperature, and humidity. So because they have specific pressure, temperature, and humidity, they make it somewhat predictable. We can watch these huge air masses moving. We can record the temperature there, the pressure, the humidity there. We can see what speed they're moving at, and we can use it to predict where they're going to be and when to help us give weather forecasts. These are another thing that make us get some of that crazy weather in the Chicagoland area, where one day it'll be like 40 degrees, and then suddenly the next day it like jumps like 30 degrees and it's 70 out. This is because sometimes we are within a cold front that is pushing down from up north in Canada, And then other days we may be within a warm front that has pushed upward from the south, like down in the Gulf of Mexico. So by definition, a cold front is the border between a mass of cold air sinking and moving in and a mass of warmer air moving out of a region. So when you're looking at a weather map and you see this little blue line with what look like little triangles or spikes on it, that's the symbol for a cold front. When this happens, it can often produce thunderstorms because what's going on is that warmer air that's in the area may have a lot of water vapor in the atmosphere. When this colder air front moves in, it cools off that water vapor, causes it to condense, which in turn results in sudden precipitation. So a lot of times when we get thunderstorms, it's because we had this nice, warm, humid air, and then suddenly a cold front moved in, cooled off that humid air, caused it to condense, and we got a thunderstorm. And another reason for this sudden precipitation and temperature change is that cold air is dense, and as we know, things that are more dense tend to sink. So as that cold front moves in, it sinks, which in turn forces the existing warm air up higher into the atmosphere where it is colder, which causes it to cool quickly and turn into condensation and rain. So when you're looking at a weather map and you see this red line with these half circles connected to it, that's the symbol for a warm front. So that means that a large mass of warm air is moving into that area. And as that warm air mass pushes into the cooler air, since the warm air is less dense, some of it gets pushed upward above that cold air, which then causes it to cool off, and you get some steady rain or snow. So along the edge of a warm front, you often have precipitation. Now, since it's that warm, less dense air, it's not the extreme thunderstorm conditions that you get when a cold front moves in, because the cold front is the high density air, so that causes a very rapid change. So when you get a cold front, you often get extreme weather change. When you get a warm front moving in, it's more of a steady precipitation. And then when the edge of that front gets past you, usually the precipitation will clear up. Now, sometimes on the weather map, you'll see a symbol that is a combination of that warm front symbol and the cold front symbol, and this is what we call a stationary front. And stationary means standing still. This happens when a cold front and a warm front kind of come together, they meet each other, and neither is strong enough to push past the other. So they just kind of stay in place, and they can stay in place for a couple days, and it often brings days of clouds or precipitation. So when we get a long period of really dreary weather where it's just kind of raining and cloudy and just kind of gross out there, it often means that there's a stationary front and you've just got warm air rising, cooling off, and dropping rain on us because it can't push past that cold front. Another symbol you might see on a weather map, and one that we've talked about in looking at weather maps throughout this year, is this big capital H. Well, what this means, you may remember, is that you have a high pressure system. This means that the atmospheric pressure is high in this area. And we're going to talk more about this later, what it really means and why it happens. But for now, we're going to say high pressure usually means that we're going to have light winds, we're going to have clear skies, so it's not going to be cloudy, and it's usually dry air. High atmospheric pressure makes those really nice, clear, blue sky days that we love. Low atmospheric pressure, on the other hand, brings some bad weather with it. This is when you'll have a lot of clouds, a lot of rain, wind, and this is because we have this warm air that is rising. It's really moist, damp air. So as that air is rising, it cools off in the upper atmosphere and produces precipitation. All right, so that brings us to today's assignment. Now that we know a little bit more about these symbols that we're looking at and about the way that weather moves, we can fill out this weather map. So this is the weather for Monday. So if you look at the chart, you can fill in the first column just by looking at what you see on this map. For the rest of the days, you're going to have to make predictions. You've got a key at the bottom that tells you the distance that the warm front is moving per day, and the distance that the cold front is moving per day. So if the warm front is moving at about 350 miles per day, you've got to use the scale over there on the left side to see how far 350 miles is. So for tomorrow, for Tuesday, you can look at that warm front and you can imagine it 350 miles to the right, because we know weather moves from west to east. So on this map, that would be from left to right. So that little symbol for the warm front is going to be however far 350 miles is to the east or to the right. And then you can write down what the weather might look like in Omaha on each of these days. So there's a little bit of math involved here. You're going to have to kind of imagine where those fronts are moving and look at the temperature that they're bringing with them and kind of make predictions based on what you know about the weather. This isn't going to be exact, guys. There is definitely some room for error here, and that's okay because predicting weather is not exact. All we can do is look at weather patterns and see how they're moving and make our predictions based on that. So if you're having any trouble with that, please feel free to reach out to me, and I am more than happy to help you out. And good luck. Don't forget to submit this when you're done. And on Thursday, I'm going to show you a lab demo. So we'll see you then.